All right, team. Welcome to the common violations practice video and data. In this, we're just going to go through. It's really hard. I don't like talking about y and x variables. I don't think that makes much sense. So what we're going to do is we're going to actually use real-world data. We'll pick a variable for y and a bunch of variables for x, and we'll test for the violations using it. Right? You should have this data available to you if you want to follow along. So what I've done is on this first sheet, especially when you're first learning these, it's kind of hard, right? It's kind of learning a new language and also what each of these are. So I've gone ahead and just outlined the 4 violations that we sort of always need to check for once we run a regression, just to make sure that we can trust the results. Just like sort of anything, if I'm going to make a recommendation from some sort of statistical test, I need to know how confident I am. Can I actually trust what I'm saying? And before I can say yes to that, I always want to check for these 4 things. And I've already split them up, again, just for practice, how we detect them. So the first 2, we're going to use the residual plots. I'll show you how to get those in a second. And the second 2, we need a correlation matrix. And I'll show you how to get that as well. So let's kind of jump on in and go through here. So I have this company income data. First thing, they're really, really large numbers. So you'll notice a profit margin's pretty easy, but earnings before interest and tax, earnings before tax, total assets, total liabilities, these are really, really big numbers, or small numbers, right? Notice this negative earnings. So if you have things like this, one, I don't like that sort of these titles are hidden. So I always go through and I double click in between the columns and it automatically fits it, and that does most of the time will get us, so we get rid of this sort of scientific notation. If you want to get rid of it completely, you can kind of manually do it. It doesn't look like it's going to do it for us. So even so big, it cuts it off. But now you can kind of see these. And throughout the class, I'll get a lot of questions that say, like, why are we looking at earnings before, so things like earnings before interest and tax, why are we using units of millions? And I'll come back to that, because right now this is a massive number, and if we run a regression and interpret the coefficient, we'll say, like, as earnings before taxes increase by $1, well, $1 is nothing, right? Look at this one right here, right? This is sort of massive. If we kind of looked at how big this would be, right? This is $1,324,000,000 in earnings. So like $1, like that's nothing. Right? So if we want to talk in units of millions or even billions in this case, we could just convert this to billions by doing something like this. Right? We could create a new column, and I'll just copy and paste this, and I'll say, we'll say, let's do millions. So millions. All we do is just do equals, and we'll do this, and we'll divide it by 1, 2, 3, by a million. Right, and now, right, this is now in terms of, right, 1,324 millions, or 1.324 billion. You could do that if you want. We do that a lot to make the interpretations easier and the numbers sort of more understandable. I'm not going to do that for this one, but I just want to let you know why we do that. Okay, first things first, let's run a regression. So in this case, what I want to do is, all right, my outcome of interest is going to be profit margin, and I think that earnings before taxes, earnings before tax, that seems odd, I know, we'll talk about it later, total assets, total liabilities, all go into determining that. So here's my y variable, here are my 3x or 4x variables. So let's just go in. You should be getting pretty comfortable at these at this point, but if not, follow along, see if you can do this. We'll do regression. Okay, and so my y variable, profit margin. I'll click on the title, I'll do Control Shift down, or Command Shift down if you have a Mac, and then my x variables are all of these. So I highlight across, and I'll do Control Shift down, Command Shift down to highlight them all. You can hit Enter or hit back on the graph, something like this. I did have labels, so I'm going to click that. Most of your alls will be set up like this. I'll go down here. You can put the output, so our output options, where that regression table goes, on a new worksheet if you want. I like to keep it next to my data, but if you're going to run a lot of different regressions, that's kind of hard to do. I also like it, especially for my Mac people doing this. If you keep it on the same sheet, your residual plots are correct. If you put it on a new worksheet, only your first residual plot is correct. So you're going to have to fix them. We talk about that in the class. There's a video on how to do that. But if you do it in the same output range, right, you don't have to fix them. So I really like this, especially I just like putting it next to my data. And I tell it where. So I'm going to put this in H2. It'll say my regression output will go there. I'll click it back down, or you can hit enter. And then, right, you have these residuals. It has it kind of ready for you. You can click residuals, but that doesn't give you the graph. I always click residual plots every time I run any sort of regression. This will give you both the residuals and the residual plots, the graphs that you want. So we'll hit OK. We get an output. Here's a regression table that you should be used to. Again, I hate that it doesn't auto fit these. So again, I always double click here. Here's the output. If you want sort of a quick trick, for some reason, like if we don't change the significance level, Excel will give us 295% confidence intervals. I don't know why it does that. I should just leave it alone. But the big thing, the new thing here are these plots. So I'm going to zoom out just a little bit here and go over. Remember, we had 4 x variables, so it should make sense that we have 4 residual plots. I'm going to kind of put these up side by side here. That way they're kind of easy to talk about. And we'll go from there. Okay, so what we use the residual plots for, and if you forget, especially before the test, come back over here and look. So we use these plots to look for nonlinear patterns and heteroscedasticity or changing variability. So when we're looking for nonlinear patterns, we're going to look for a nonlinear pattern in the residual plot. So I go over here. First off, and we talk about this in the lab. If you haven't done it yet, you will. This plot here doesn't really tell me anything. What Excel is doing is it's trying to fit all of your data into one picture, which is good, but also it can be bad because I can't really look for there to be any pattern here. What I usually do first, before I start messing with the axes to kind of look where the majority of the data is, I'll get one plot by itself, and then I'll make it bigger, and then it kind of auto adjusts. I can kind of see a pattern with this one, but still, like, this is a huge outlier. Like, I don't really care about it, and it's really keeping me from seeing a full pattern here. So what we want to do is format these plots so that I'm looking at most of the data. Again, these are residuals. This is not actual data points within the data. They're not XY pairs. It's residual on the vertical axis, so error, and then my X variable. So what I'm going to do is I'm going to click here. For a Mac, you can do control click. For a PC, just right click, and a drop down should pop up. Again, some people like click over here and they don't see that. You have to actually click on a number and then right click, do format axis. I'm looking here. I noticed that most of my data is kind of below this 50, 55-ish range. So I'm going to set my maximum at 55. And it looks like I have some data here. Right? Most of it's between above -25. So let's just set that -25. And now I can see that that's much better than, remember, it looked kind of like this at the very beginning. Like, I had no idea what this is. Well, now I can kind of see if there's a pattern. And even now, like, I've got a lot of outliers over here that I might not care about. So you can do the same thing with the horizontal axis. So I'll click on the axis, and then if you're already clicked over here, this will pop up. But if not, again, you'll have to do, click on a number, you'll right click, and then do format axis. And we'll do here. And so I don't see much left of 0, so I'm going to set the minimum at 0. And then, so I'm kind of looking around here, 2e to the 10th. Let's just change this to, let's just make that the maximum and just see what happens. Right now, I can see most of my data. And here's where I'll start looking for patterns. So the 2 patterns that I'm looking for, back over here, nonlinear patterns. Well, I look if there's a nonlinear pattern in the plot. So if I see anything that looks like a curve or something like that, or what if I see a funnel shape? If I see either of those things, we have issues. So I go over here and I'm looking at this, and to be honest, different people might see different things. In terms of nonlinearity, this doesn't look like, I don't think I can fit a parabola in there, or a curve like this, or an exponential. It doesn't really make sense. So I think I'm okay with a line here, right? A linear looks okay. In terms of changing variability or the funnel, I personally don't see much, but you might be able to argue with me, right? Okay, well, so here early, I've got a really wide variation in the errors. So my small values of earnings before interest and taxes, I'm making a lot of large errors. And then as I get kind of to these bigger companies, I'm noticing that the pattern gets a little bit tighter. So if you said heteroscedasticity might be an issue, that's perfectly fine. You just need to know how to fix it. And I probably would, just to be safe, maybe try and fix it. But that's what you're looking for. So in this case, you might see a small funnel. I don't really see any sort of non-linear in here. Maybe you do. We could try it. We'll talk about how to do that in the later chapters. But in terms of that, I think this looks okay. So let's go quickly just look at the others. So earnings before tax and earnings before income and tax will look nearly the same. You can play around with the axes if you want. Total liabilities and total assets. These look a little different, so let's play around with this one. So I'll move this down, and then let's start off. Let's just make it bigger, something like this. And you'll notice I have thousands of observations, but my data is just right here, really small. So let's format our axes again. So let's say we don't see this, but I'll click here, and then right click or control click for you Mac people. Hopefully you have a mouse by now. It makes life a lot easier. Let's set the minimum at, let's go negative 25 again, and then Excel will update for us here real quick. I don't know why it does that. But then again, most of my data is below that sort of 75, so let's set it at 70. And again, if you don't like those, you can play with whatever you want. The goal is so you can get a picture of most of your data. Again, I don't like these outliers here, so I'll click here, and if you stay clicked on here, I don't have to mess around, but if you've clicked off, you might have to go again. So 0 seems like a good lower bound. I've kind of already played with this data, so I already know that I want to set my maximum at 1e to the 11th. And again, you can kind of set it to however you want, whatever works for you. Make sure I can see most of my data. I could see it if someone said, let's just change it up. Let's not be predictable. Let's go 6e to the 10th. Again, I just want to look at data left of this. I'll hit enter. Looks pretty good. And so now let's look at the plot. So number 1, do you see any sort of non-linear pattern? Right? Do you see a quadratic or an exponential or a logarithmic or a cubic? I don't. I see this as pretty random, which is ideal. Right? Students struggle. What do you mean I'm looking for random? You think this is a data plot. It's not, right? It's X variable versus errors. We want our errors to be random. So no pattern is really, really good. We can look for the second one, so heteroscedasticity or changing variability. Same thing, whatever term you like. If you're talking to your parents, tell them you're testing for heteroscedasticity in company income data, and they'll be super impressed. Or they'll only stop talking to you if that's what they want. But what we're looking for is a funnel. In this case, right, you could have really, really tight to very, very wide, or vice versa. I don't really see it, to be honest. I see a lot of data kind of around here, and there's no sort of discernible pattern. So I think we're okay with heteroscedasticity. Okay, so we're good. So those first 2 violations, I didn't really see either of those. We'll briefly talk. So if I did have nonlinear patterns, what happens? Well, when I'm going over here and I'm doing my hypothesis testing, I could find, right, that a variable that matters, so something like total assets, that has to impact profit margin. Well, I could see that it's insignificant. You'd be like, well, that doesn't make any sense. Well, it's because maybe there is a curved relationship. So the big problem with that is we'll say variables that are statistically significant, things that should matter are not, which is dangerous. And then heteroscedasticity, when we have that, we can't trust this test statistic, p-value, or confidence intervals. We can't reliably say whether something is statistically significant or not, whether it is impacting our variable of interest. So we don't have those issues. So right now, I can trust what I see from Excel just from those two. So I'm going to go ahead and just delete these to get them out of the way. Let's check our other two here. So our other two, multicollinearity, we're looking for a strong correlation, greater than 0.8, less than -0.8, between the x variables. So only my x variables. And then endogeneity or omitted variables, I'm looking for a statistically significant correlation between an x variable, any of the three x's, and the residuals. You could do each of these separate, right? I could do a correlation matrix for this, just the x variables, and go. Or I could just do a correlation between all the x variables and the residuals and go. That'll take forever. We want to be as efficient as possible with these. So what we always, or what I typically like to do is, let's do it all at once. And the nice thing is, we'll go back over here. If you click that residual plots button, you'll notice if you go right underneath your output, it gives you this residual output, and then right in this column here, it says residuals. Right? There are your residuals. Right? You don't have to go through and calculate, plug all the stuff into the equation. It's done that for you. So what we need are, we now need our x variables. So our x variables in the model were earnings before interest and tax, earnings before tax, total assets, there's lives. So what I'll do is highlight it across. I'll do Control-Shift down to highlight it all again. I'll copy it. Don't cut it, please, just copy it. We'll go back up. We'll paste this right here. So just Control-V, Command-V, whatever you're comfortable with. And then again, if you're like me and you don't like these things to constantly be not why. All right, so now you have all your data. You have all your x variables and your residuals. What we need to do is calculate a correlation matrix. So we'll do data analysis. We'll do correlation. We'll hit OK. And we want all of our data. So what I'll do is I'll highlight across. Don't forget to get residuals in there. You don't need predicted profit margin. So just do residuals all the way over to total liabilities. You can do Control-Shift right if you want, if that's easier. And then do Control-Shift down, highlight it all. Make sure, most of the time it doesn't have this, but click labels in the first row because we have those headers. And then again, you can put your output on a new sheet. These are correct for Mac or PCs, or you can go on the range. So I kind of like these. So I got to click on the graph. I like to have them next to all my stuff. So I'll put right here. I'll do this. I'll hit OK, and here's my output. And again, damn Excel doesn't auto format these things, so you're like earnings, like what is this? And we'll go through here. So what we'll do, I just like to expand all these. So here's a correlation matrix. All right, here's my residuals, here's my x variables. Let's check for the two violations. Let's go in order. So multicollinearity, look for a strong correlation between the x variables. So my x variables, and I do not care about this column yet. When I'm looking for my multicollinearity, I'm going to be right here. So this tells me, and if you're struggling reading one of these matrices, we have it at the end of the chapter. But it's right, we just talked about, so this is right correlation between earnings before interest and tax and earnings before interest and tax. Well, duh, same variable, it's going to have a correlation of 1. I have it here, earnings before tax and earnings before interest and tax. Right, the correlation is 0.99. So I'm going to put a big bold there. That's saying, right, clearly, and this should make common sense, there is a high correlation between earnings before taxes and earnings before interest and tax. Duh. Duh. Kind of same one. So what we're looking for is a cutoff of 0.8. So I go through here, right, these are high but not high to concern me. These are high, not to concern me. Here's another one. And this again should make common sense as well. Right, notice there's a high correlation between total liabilities and total assets. That's just kind of where these line up. Again, duh. A company with higher assets likely also has higher liabilities. So I'm going to have potential issues with multicollinearity in two places. Right, my earnings before taxes and earnings before interest and tax, and then my total liabilities and total assets. Duh. So what does this cause? So when we have these, when these two things, when two variables move together, Excel is struggling or will struggle to figure out which of the two is actually causing my Y variable to move. So which is causing the profit margin to be impacted. So essentially it makes it harder to find statistical significance. So I go over here, here are my two problem ones in the first case. I look at my p-values. Well, it's saying earnings before interest and tax, earnings before taxes don't matter. Right? I'm between 15% unsure and 80% unsure, 81% unsure. Well, come on, right? Come on. Earnings before interest or earnings before interest tax have to impact profit margin, right? That's just kind of common sense. So how do we fix that? A couple different ways. We could transform one of these two variables. We'll talk about that in 6. We could get more data. Well, that's hard right now. We can't really do that. We could drop one of these variables, and I'll do that at the very end, because these are the same thing. They're capturing the same thing, so we could get rid of them. But we wouldn't just want to say, like, they don't matter. So let's look at total current assets and total liabilities. Even though I have multicollinearity, I'm finding out they're both statistically significant. So honestly, I wouldn't worry a terrible amount for these, and the coefficients kind of make sense. So I might do nothing, right? Especially if I had a high R squared and low standard error. The problem is this is a really low R squared, and it's a pretty high standard error for profit margin. But we'll talk about it, we'll fix that. We'll fix this one here kind of in the end, because I want to talk about the last one here. So last one, endogeneity omitted variables, worst ones, right? When this happens, I can't trust these numbers. I can't I can't interpret those how we have in the past. I can't say what or how each variable is impacting profit margin. So how we test for that is we want to look between the correlation between the X variables and the residuals. So here's my residuals column. So here's the one I'm looking at for endogeneity. And I'm looking for sort of any worrisome number. Notice that all of these are extremely small, right? 15 decimal points to the left. So to be honest, I would look at this and say, there's no way that's going to be statistically significant. If, on the other hand, we were going to see, or we saw like a 0.2 or 0.3 or 0.4, we would actually want to go in and do sort of our correlation test like we did at the beginning of 4. But if I saw those, I'd be set. I'm not worried about correlation or endogeneity. Right, so those are all 4. Just a quick fix here. So one of the fixes for multicollinearity is just to drop one of the collinear variables or highly correlated variables. So what I'm going to do is I'm going to delete this, and I'm going to run this regression with just these, so this Y variable again, and these 3 X's. So I'll do data analysis again. We'll go through regression. Okay. So again, I want to predict profit margin at my input range. I'm going to have to change that. I only want these 3. I'll do Control Shift down. I'll go ahead. Let's just put this on a new worksheet, so I don't have to override everything. And we'll hit OK. It pops up. Don't worry about the residual plots. Now I look. Right, earnings before interest and tax, I go through, boom. Right, now it's statistically significant. Right, Excel isn't trying to battle and figure out which of these two things is actually mattering, because they capture the same sort of information. Right, now we have a statistically significant variable, and again, I just randomly chose which one to drop. You could have dropped this one and kept earnings before taxes only in there. And you should have found something they like as well. All right, that's it. I hope this was helpful in the practice, and you understand, right? If we don't do these tests, I could lie, right? If I came over here and I used this and I didn't test it, I'd go to my boss and say we don't need to worry about earnings before interest and tax or earnings before tax because they don't matter. Your boss will probably be we should stop looking for earnings, I guess. Well, you don't want to do that, right? You don't want to make that dumb mistake. You don't want to look dumb. So we always need to test for those 4 things. And once you get comfortable with these, you can do them in sort of a minute or 2. And other programs make it even quicker. I hope this was helpful. Have a great day, and let me know if you have any questions.